For 40 years, the world was built on a single language, binary. We mastered the silicon chip, the internet, and finally, the autonomous agent. But in 2026, we've realized that the most powerful computer ever designed wasn't built in a clean room in California. It was grown in a cell. We are entering the era of programmable biology. In this new landscape, DNA is no longer just a blueprint of life. It is a functional source code that we can edit, compile, and execute with the same precision as a software update. This is the biodigital convergence. It's a world where the line between hardware and organic is disappearing. Today, we're decoding the massive value creation behind the synthetic biology revolution. We'll explore how cellular factories are replacing industrial manufacturing, why biological data storage is the next goldmine, and how we are finally engineering our way out of scarcity. Welcome to Capital Chronicles. For over a century, manufacturing meant extraction. We took raw materials from the earth, used heat and pressure to reshape them, and accepted massive waste as a byproduct. In 2026, the unit economics of production have been fundamentally rewritten. Instead of building a factory, we are now coding a microbe. Using advanced synthetic biology platforms, companies are engineering yeast and bacteria to brew everything from jet fuel and sustainable textiles to carbon-negative concrete and high-performance electronics. This is generative manufacturing. Because these cellular factories grow at room temperature and consume waste as fuel, the cost of production is plummeting. We are seeing the rise of bio-stated economies, where countries are no longer dependent on global supply chains, but on their ability to cultivate their own domestic bioreactors. The catalyst for this boom isn't just biology, it's the AI agents we discussed in our last episode. In 2026, we have achieved closed-loop discovery. AI models now simulate billions of genetic variations in seconds, predicting how a new protein will fold or how a cell will react before a single pipette is touched. This has collapsed the timeline for drug discovery and material science from decades to months. We are moving from finding solutions in nature to designing them. We aren't just treating diseases anymore. We are engineering the human immune system to act as an autonomous defense network, capable of identifying and neutralizing threats before symptoms even appear. This is the personalized bio-revolution. As our digital world expands, we've hit a storage crisis. Silicon-based servers are too hot, too fragile, and too small for the massive datasets of the 2020s. The solution? DNA data storage. In 2026, a single gram of synthetic DNA can store 215 petabytes of data, and it can last for thousands of years without a power source. We are seeing the first bioarchives being built, where the world's most critical information is being encoded into organic sequences and stored in climate-controlled vaults. The companies that control the synthesis and sequencing of these data organics are becoming the new masters of the cloud. It's a $500 billion pivot that most investors haven't even noticed yet. With this power comes the ultimate responsibility. The story of 2026 isn't just about profit, it's about the ethics of the edit. As we gain the ability to rewrite the code of our planet, we must decide what kind of world we want to grow. The biology boom is the engine of a more resilient, circular, and healthy future. It's an era where we stop fighting nature and start collaborating with it. We are building a world where the spark of human ambition is finally matched by the infinite complexity of life itself. To keep track of the innovations and strategies defining this new golden age of biology, you're in the right place. Subscribe to Capital Chronicles and join us as we explore the positive forces building a better tomorrow. Thanks for watching. Thanks for